Our video presentation will be on the topic Techniques of Differentiation, and I would like to introduce our team members.
My name is Miles Maya Marius Benedict. I'm from CDCS 110.
Hello, my name is Bryden Erwin Boylis from CDCS 110.
Hello, my name is IG Elias Laison and I am from CDCS 110.
My name is Daniel Adnan bin Haminin and I'm from CDCS 110.
My name is Miles and I will be presenting on question 1. Explain the meaning of differentiation and what are the techniques of differentiation. Differentiation is the process of finding the derivative of a function. The derivative measures how a function changes as its input changes. In other words, it gives the rate of change or the slope of a function at any given point. For example, if y equals to fx, then the derivative of fx tells us how much y changes when x changes by a small amount. Differentiation techniques. Constant rule. If the function is a constant, then its derivative is 0. Power rule. The power rule is used to differentiate functions of the form fx equals to x power of n, where n is any real number. The derivative form of x power of n is equals to n times x to the power of n minus 1. That's because we have to bring down the exponent n and multiply it and subtract 1 to the original exponent. Product rule. The product rule is used when you're differentiating a function that is the product of two functions. Fx equals to ux times vx. The derivative form of function fx will be u prime x times vx plus ux times v prime x. Quotient rule. The quotient rule is used to differentiate a function that is the division of two functions. Fx equals to ux over vx. The derivative form of fx would be u prime x times vx minus ux times v prime x over vx squared. Chain rule. Used when differentiating a composite function. Fx equals to hgx, then the derivative form of fx would be h prime gx times g prime x. We would need to differentiate the outside function, keep the one inside remain unchanged, and multiply by the derivative form of the inside function.
So now we're going to solve question 2a and we're going to use product rule to solve this question, that is dy over dx equals to uv prime plus vu prime. So by getting all this equation right here, we can just insert it to the product rule and we got it this here. This part right here, we can also simplify it. And how do we need to simplify it? By just expand it. Let's say 2x is equals to 1 over cos 2x. So we just need to change it 1 over cos 2x and 1 over tan x. Then this tan x, we also need to change it to cos x over sin x. Then we just need to cross it out. By already crossing it out, we can get 1 over cos x times 1 over sin x plus 2x ln tan x. Now we're just going to multiply these two, and by multiplying these two, we get 1 over sin x cos x. So we're going to change this one by using trigonometric identity. So 1 over sin x cos x is equals to 2 cos x times 2x. So this is the one that we're going to change into the 1 over sin x cos x one right here. And then we just multiply it. So we got 2x square cos x times 2x plus 2x ln tan x. So that is the final answer. Now we're going to solve question 2b. The formula that we're going to use to solve this is quotient rule, that is dy dx over vu prime minus uv prime over v squared. As always, we're going to find u and u prime, that is this one. Then we're going to insert it at the, inside the quotient rule. We got this part open it up so that we can cancel out this, right here. This part we're just going to multiply it. So now after we multiply it, we got this part right here. Then we need to factorize the equation, the exponent. Then we got this one right here. So this is actually the final answer.
Hello, my name is Bryden Irwin Boylis. I will be explaining question 3 step by step. The question 3, y ln 3x negative cos 4y equals x power of 3 minus e power of 2x power plus 1. It asks us to find the dy over dx using implicit differentiation. So moving on to the solving method, the first step is to differentiate both sides of the equation with respect to x. Since y is a function of x, we must use the product and chain rules. and we need to separate this into the left side and this into the right side. So the second step is to apply product rule to y ln 3x, and we need to treat y and 3x ln 3x as a separate function and apply the product rule. So y is equal to u, and the u prime of y is dy over dx, while ln 3x is the v prime is 1 over 3x bracket 3, and we can eliminate the 3, so it can become 1 over x. So for negative cos for y, we need to apply a chain rule, and as you can see, it became negative bracket negative sin for y bracket for dy over dx. And since negative and negative, it will become a positive, leaving it as sin for y bracket for dy over dx. And can move the 4 into the front, making it 4 sin for y bracket dy dx. So let's handle the right side of the equation. For x power of 3, after we differentiate, it will become 3x power of 2, while e minus power of 2x plus 1, we differentiate, it will become negative e power of 2x plus 1, and the bracket 2. So after we done differentiate the left side and the right side, we need to put back in the equation, and as you can see, I already put the equation back in, and for this, it can become more simplified, making it y over x. And after that, we need to isolate dy over dx by grouping the terms. So the equation that doesn't have the dy over dx need to move into the right side. So as you can see, after I move y over x, it will become negative y over x. And we need to isolate this too, and it will become ln 3x plus 4 sin 4y. After that, we move it into the right side, so it became the 3x power of 2 minus 2 e power of 2x plus 1 minus y over x over ln 3x plus 4 sin 4y. And that's how we find dy dx using the implicit differentiation. That's all from me. Thank you.
Hello, my name is IG Elias Lyson, and I will be explaining question 4. So the question asked us to use linear approximation to estimate the value of this equation correct to 3 decimal places. So first of all, we have to know the formula for linear approximation. I have written it down here, and it's given that x is equal to the initial value, x naught is equal to the estimated value, and delta x is equal to initial value minus estimated value. So step 1 is to find these 3 values. So let's start with x. So from the equation, we let 0.98 be x, and then for x naught, we pick a nice value to work with. In this case, I pick 1 because it's a whole number. And then after we get these two, we plug it into the delta x formula, and we are left with negative 0.02. Now that we have all these 3 values, let's move on to step 2, which is to find f of x and the derivative of f of x. This part is relatively easy, as we just have to replace all 0.98 with x. So f of x is equal to ln x minus 3 over the fourth root of x. Now we have to find the derivative of fx. We have to perform and we have to apply multiple differentiation technique. And after we did all of that, we are left with 1 over x plus 3 over 4 times the fourth root of x to the power of 5 is this. Finally, we can go to step 3, which is to plug the value of x naught into f of x and the derivative of f of x. So since x naught is equal to 1, we first work with ln 1 would give us the value of 0, while plugging it into the fourth root of x will give us 1. So we're going to be left with negative 3. Now we have to find the value of f of 1 in the derivative, I'm sorry. So after plugging it in, we're going to be left with 7 over 4. Now that we've got all of the values, we can substitute all of them into the formula of linear approximation, which is this. You can see here that the final answer would be negative 3.035, which is in 3 decimal places as per instructed. Thank you.
Differentiation is a way to find out how things change. Differentiation is important because it was used in science to find out speed in motion. In conclusion, differentiation is important part of math that we can use in many real-life situations.